Hi, everyone. Welcome to the Solar and Storage Market Series. My name is Erez Dolev, and I'm the Managing Director here at Renvu. Today, we're going to be hearing from Greg Smith, the author of Amazon #1 bestseller, Battery Powered Home. And we will discuss everything about energy storage, and you will have the opportunity to ask any question you might have about energy storage at our Q&A session. And we will get to those questions at the end or in the middle of the presentation if it's relevant for the slide that Greg is going over. But before we dive in and while we're waiting for more people to join, I'd like to give a little background on Renvu and some of the products and services we offer. Um, so Renvu is a US-based solar equipment distributor. We've been in the industry since 2012, and we're currently have fulfillment facilities in California, New Jersey, and Texas. Our sales staff all have background within engineering and solar installation. A few products quickly to spotlight here. We carry the whole solar portfolio, HomeGrid, GrowWatt, Soluna, Discover, Renon, and Fortress Power batteries, and can beat any price you see out there. We also have some offers on our website for these with free shipping and huge discounts, so worth checking it out. We have the Solar L3 commercial battery banks paired with the three-phase 30K and 60K inverters. The 30K can be operating 208 volt environment. We carry the Lumin ABB Smart Panels. This is a great device to add to a solar and storage project since it allows you to use the existing main and sub panels and control the loads remotely during power outage or set rules for which loads will continue to work and which ones will be dropped. We have plenty of Runnergy Hyperion, 405 Blacks, 550s, and 575s modules. We have the whole portfolio of Enphase IQ8 series. And if you're looking for T-gaskets to make the solar array watertight, Bleaker has several options for different modules gap sizes. We also have about 400 of the Kohler CATL LFP 2.5 kilowatt hour batteries. We're selling now for only $480 each. So that comes to $192 per kilowatt hour. And with the new tariffs, this is a great opportunity to get storage for a really low price. I think that for a 10 kilowatt system, you will pay $1,900 for the, which is pretty great. We'll share a link to the product on our website in the follow-up email. We partnered with two financing companies. Credit Key offers credit lines for up to $50,000 with approval in a few minutes and can increase the review of 3 months of bank statement to up to $250,000. Build is another financing option that is designed for C&I projects. Your credit line will be approved based on a specific C&I project, and you will be able to use it for other business purchases as well. Build will also give you a rebate of 0.5% of your purchase with Renvu. So next time you have a C&I project, we recommend you to contact us to set up your credit line with them. Here's a bulk module price list for large volume options and our upcoming offerings of solar modules. This is a part of it, but we'll share a link to the full file in the chat in a second. We carry Runnergy, Zenshine, Canadian Solar, Q-Cells, Hyundai, Telsun, and more. Let's see, I have another here. This is another offer that we have this week for 19 cents per watt for these modules. We have their Telsun we have some 385s as well, Longi 375, SunPower 330s, Hyundai 390s, and Visan 410s, everything under 20 cents. So worth checking it out if you're looking for this type of modules. take a minute to also mention the Bleaky residential carport. This is a great way to expand existing solar system or an alternative solution where you cannot install solar on a roof. And when customers is looking for more added values from the solar system. Let's see. Okay. That's a short version of the installation video. The carport is designed to be assembled by a small crew. It doesn't require any specialized or heavy machinery to install. This is a solar structure, so it's eligible for the 30% ITC and possibly extra 10% for US made products, all domestic sourced steel, and the fabrication is done here in Utah. This is a solar structure, as I said, and it, it is a module and inverter agnostic, and it designed and fabricated in Utah and carry 25 years warranty. The structure is coming with a Texas Structural Engineer P stamp. If you need it for any other state, we're working with a firm, engineering firm called Illumini. They will stamp it wherever you need it. You can install up to 24 solar modules with 4 columns of 6 modules. And the two-car carport will generate about 10 kilowatt power. You can use residential and commercial modules with it. Load capacities of 48 pounds per square foot of snow, 215 miles per hour wind load, and seismic design category F. We'll share a link to the full version of this video. If you have any questions about these products or about energy storage while Greg is presenting, please feel free to ask it on the Q&A section. There is a button on the Zoom pan, and we will get to the questions either at the end of the webinar or during the webinar. You can also email our sales team at info@renvu.com for more information and pricing. This webinar is being recorded, and we will send you a link to a follow-up email. We also have recordings of previous webinars on the Renvu YouTube channel if you're looking for those. And without further ado, I will hand it over to Greg.
Awesome. Thank you so much. Man, that carport looks super easy to put together. Like, I love videos like that that are able to just, very quickly show you how that stuff goes together, right? No special tools and no like cranes or anything like that. That is really neat. I would love to get one of those here, but I'd have to wait. So if you remember last time I was here, and thank you again, Eris, for inviting me back. Uh, Although, we were talking before, I'm sorry that I'm not going to be able to do any more videos from my garage. So we'll have the nice, pretty Little Red River behind me, if you can see that. But the opportunity to speak for Renvu is always appreciated, and to let me pitch my book is a double bonus. Can you see my presentation now?
We see our slide.
Awesome. Awesome. Okay. So this has been my passion for about 17 years. I can't believe that I've been doing this long. A couple of weeks ago was the continuing education conference for the NABCEP organization, North American Board of Certified Energy Practitioners. And it was out in Reno this year, which I always like that area. And it's always a good time to be able to talk shop. Like, it's just a bunch of solar nerds like me together for a whole week. And I love that environment. And I love talking about batteries since they are becoming so commonplace now, right? So, like, batteries not included. Well, that's not the case anymore, right? And regardless of what state you're in, a lot of things happen in California and they tend to move east, whether you like it or not. And as more and more antagonistic utilities start messing with rates and, getting rid of the incentives and rebates, batteries just make a lot more sense now. And I remember many years ago when I was at SMA, I was talking to one of the sales guys. He said, "Oh, Greg, like in 5 years, it won't make sense to sell solar without a battery." And he was about 5 years off, uh, but it came true. And so we see a lot of places in the US where people have solar installers. They have high attachment rates to their solar now because the batteries just give you so much more bang for your buck, particularly when you have high utility rates, right? Like California, right? Like they were, oh man, sometimes it's 40, 50 cents a kilowatt hour, right? And so, why not install a battery with your system and use your battery at night and charge it during the day? And yeah, it's just a great win-win for everybody. Well, except for the utilities, but who cares about them, right? So I'm going to talk about these things very quickly. Matter of fact, in my book, I talk about terminology right up front because I see a lot of people in this industry that use the wrong words. And so I'm going to use the right ones. And the first part of this, we'll talk about terms and terminology. And I know people are like, oh man, come on. Like we get really got to go over this stuff. But we do. It's important so that everybody gets on the same page. Okay. I'm going to show you what an electrical system looks like with solar and storage in it. There's two different ways that installers like to do this, either partial home backup or whole home backup. So we'll compare and contrast that. We'll look a little bit at the type of chemistries that are out there for lithium, and we'll focus in on the two main ones. And then we'll just talk about battery bank sizing because I think that is a common deficiency in our industry that causes a lot of service calls. I work at Tigo Energy. We launched a battery solution about 3 years ago, and poor battery sizing takes up a sizable chunk of our service calls, and it could all be prevented pre-sale with just a little bit of effort. Yeah. So we'll talk about terminology first, and we're a lot of the terms I'm going to talk about relate to commercial storage, even utility scale storage, virtual power plants, things like that. But we're going to focus on the ones that have to do with residential for the most part. So the one thing I see people mess up a lot is power, right? So power is just a description of how fast your electricity is being used, or if you have a solar inverter, how much it's being generated, right? And so if you get a little nerdy and use electrical terminology, power is defined as work. And work is either lighting a light bulb or charging a battery or discharging a battery, running an electric motor, anything that is using that electricity is called power. Okay. And we know from school, depending on where you went, that power is related to voltage and current, right? And we have the little power triangle here. And so I always love this thing. Matter of fact, I have this in my book. So if you want to know what what the power rating or how much power something is making, well, you look at the P, that stands for power. I is current, stands for intensity. Okay. And so if you want to know how much power you have, you got to take current and multiply it by voltage. And conversely, if you have the voltage and you want to know like what the power is, well, then you would just again multiply that by current. And then you can do a little division to find the other ones, right? So we're not going to nerd out about that too much. But one thing we do need to know is the unit of measurement for power, and that is the watt. Okay. And for inverters, the numbers go quickly from watts to kilowatts or thousands of watts. So we kind of use the metric system for these units of measurement because it's just easier. Yeah. And so typically you're getting into megawatts, you're talking utility scale stuff or large commercial building, or you're looking at large solar systems, right? Megawatts of power, right? Those are huge. And a megawatt array, generally speaking, takes up about 5 acres of land, okay, for 1 megawatt. So as you're driving around, if you've been in the industry as long or longer than I have, you start to notice these arrays on the side of the road. And I was so happy driving around my home state of Arkansas a couple, 3 weeks ago, where I saw some large arrays on the side of the road. I was like, all right, cool, man. Solar's gaining some traction here in Arkansas. So you'll start to do that same thing. You'll start to be very aware of the solar around you. Okay, so we look at a nameplate here. This is actually my 5,000 watt Sunny Boy on my house in California. And if you look somewhere on the nameplate, it will tell you what the max continuous output power is. And this is 5,000 watts. Now, for a lot of equipment, typically the name of the model will tell you how much power it's capable of producing. So this SB 5.0, that means it's 5,000 watts. 1SP means it's a single phase inverter, right? So even the product name or model can tell you a lot about what's going on. And so we see here that this inverter can work on either 240, which is what most residential applications use, or it can work on 208 volts. So generally speaking, 208 is a commercial voltage. So line to line is 208, 120, line to neutral. However, even in my home state of Arkansas, typically in upstate New York, or even out in Utah, places where there are large farms that are relatively old, they may have 208 running to the service there. Yeah, because that's what they used way back when for large agricultural pumps and things like that. So you may, if you're an installer, you may come up every once in a while on some out in the boondock somewhere where that house is 208. Not an issue because most modern inverters can operate on 208 or 240 and they auto sense that. Right. So if it knows it's on 208, it just sets everything up. You don't even have to do anything to tell it to work on that voltage. Yeah. And so if we apply a little bit of what we learned from the previous slide, if you want to know for example, how much the overcurrent protection, the breaker would be, you could take 5,000 divided by 240 and get 20.83. And then you would multiply that out and come up with a 30 amp breaker or whatever the value would be. But we see here that when the voltage goes down for 208 volts, the current has to go up because that inverter still has to make 5,000 watts. So if it's 240 volts, it makes less current than it is when it's on a 208 volt service. Kind of cool. Numbers always work out that way, right? Now, contrasting to power, which is measured in watts, we look at energy. And energy is measured in watt hours. And I see a lot of people messing this up. They say, oh, yeah, I just installed a 30 kilowatt battery. I'm like, wow, that's a lot of power. Like, what are you running? Like arc welding equipment or what? And what they really meant to say was they had a 30 kilowatt hour battery. And that kilowatt hour describes how much the batteries can hold. Okay. And we use that for all batteries, right? So watt hour is how much electrical power is either produced by inverters or the grid, or how much it's used in your home, by your appliances, or how much is stored in your lithium ion battery bank, right? So it has a lot of utility here. And just what we're looking at here, these are typical cells that are used in battery banks now, right? You may not see those. They're about the size of a double A battery, but I'll get more into that here in a minute. But that's what lithium ion cells look like, at least one kind of cell, right? And watt hour, to figure out how many watt hours you're consuming, you need to know the power multiplied by how long that thing is running. And that gives you watt hours. And believe it or not, this is on your utility bill. And in my experience, not many people know how many kilowatt hours they use during the month, but they know how much they pay, right? Generally, everybody knows how much they're paying a month, but they don't know what they're consuming. Yeah. Okay. So we look at this. We look at a light bulb. I remember my dad yelling at me all the time for leaving the lights on in the house. And this is just a good little theory to practice. So if you just take a 40-watt bulb, like on your porch light, and you just left that thing on all day, all right, that's 90, or excuse me, 960 watt hours. So, not even 1 kilowatt hour, right? But if you extrapolate that out in a month, and if you're paying 14 cents a kilowatt hour, that comes out to about $4 a month just to keep that light bulb on. And it may not seem like much, but if you're running on batteries and you have, bad weather, like if it's cloudy or rainy, well, all those watt hours start to add up. They really do. All right. And so we look at something a little bit bigger, right? And I get this question all the time. So I do have an author website called snarkysolarguy.com. And I talk about this a lot, and I get a lot of consultation requests a year, mostly for off grid, but also for other things, residential. And I love it. Like it's a great side gig, and I love helping people with that. And the one thing that I really have to bring people, down to reality is their air conditioning use, particularly in people in areas like the desert Southwest, right? Where not having an air conditioner running is not an option, right? They have to run this. It's 120 degrees outside or more. So they have to have an AC. And that's fine as long as you know what you're getting into. Because I guarantee you, one battery, like a power wall, right? And I hear this all the time. Oh, Greg, they said that this battery would power my whole house. I'm like, well, yeah, it probably will. But if you're running air conditioning and things like that, it'll probably only run your whole house for about 15 minutes. Right. So that's the part they're not telling you. So you have to know what these large loads are pulling. Right. And so what a lot of people do is if they have a large load like this, excuse me, and if it's like in the wintertime where they don't need it, they just won't run it. Right. They don't have to worry about it. But we can dive into load management and the Lumen Smart Panel and the Span Panel and things like that for real serious load management, and I highly recommend those. But I could spend a whole hour on that, and we just don't have that time. So let's look at something, another theory of practice here. So this is where I used to live, right outside Sacramento, and so annually, my 5,000-watt system would make just, we'll just call it 8,000 kilowatt hours. Okay, that's a year. But when you're designing a battery system, you have to look at some other things here, right? So typically, July is the month where you have the most sun hours. So I make about 31 kilowatt hours a day with that inverter. Now, my air conditioner takes about 3,000 watts when it's running. Okay. And so you multiply 3,000 times 8 hours, which is about how long um, an air conditioner runs per day, about 8 hours. Um, that 31 kilowatt hours that I'm producing is only taking care of about a third, if I'm lucky, of my air conditioning. And if I have a 20 kilowatt hour battery, that air conditioner is going to suck that thing dry so fast. Yeah, and numbers don't lie. So when I'm consulting or when I'm training salespeople or anyone, I really press on these large loads. And it only goes from bad to worse when you look at December, when my poor 5 kilowatt system is only going to make 10 kilowatt hours. That's nothing. A refrigerator takes 2 kilowatt hours a day. So that leaves me 8 kilowatt hours for everything else. Oh, I got a freezer. That's another 1.5 kilowatt hours. So you see how these loads just start whittling down how long you're going to be able to run those loads. And this is the biggest pitfall that I see when people jump blindly into energy storage. Now, state of charge is another one that we need to know. And this is very familiar to people, even if you have never heard the term. Okay, state of charge is what your phone shows you in that upper right corner. Okay, that's state of charge. And that's basically showing you how much of the battery you have used. And we all know when it gets to 20%, it turns red, and then everybody starts flipping out, right? We start looking for somewhere to plug in, and our hearts start racing, and our stomach's getting in a knot, right? Well, if it does that with a cell phone, just imagine what happens if you have a $30,000-$40,000 energy storage system that's starting to get low. Yeah. So a 100% state of charge means that battery's full. Yeah. You get down to 50%, well, you got half of it left. When it's 25%, you got a quarter left, and 0%, oh boy, I hope we never get down there. But that is a dead battery, right? Dead. Not dead in the sense that you won't be able to recover it. It's just off, right? But most, I'll just, never say always or all, but I'm going to I'll just make that rash statement now. All energy storage systems will go into standby mode long before they reach 0%. Okay. If an energy storage system reaches 0, something went wrong, and there was probably a lack of customer education that prevented it from not going to 0. Yeah. Now, the inverse of state of charge is called depth of discharge. Now, if there's any lead acid people out there, like what I grew up on, you know this term well. And DOD, or depth of discharge, is the inverse of state of charge. It's telling you how much you have left in the battery. Okay. And so we look at this 75% depth of discharge means you have 25% left. Right. And so 25% is pretty low. Right? So for lithium ion batteries, the only time you will see depth of discharge is on a data sheet where it's talking about how much you can use of that lithium ion battery, right? And you'll see a lot of them that say 100% depth of discharge. Almost all of them say that. Okay, I'll tell you right now, that's marketing baloney. No lithium ion battery can go down to 0% more than once. And even that's debatable, right? It's like IKEA furniture. You can take that thing apart one time and that's it. You do it more than that, it ain't going to go back together. Same thing with a lithium ion battery. If you get below 5%, you might be able to recover that battery once. Okay. But if it gets down that low, that usually to me indicates poor sizing. Okay. Not always, but most of the time. Okay. So discharge. This is kind of a familiar term, but this is how much is stored in the battery that is then discharged or used by the appliances or whatever you're powering. Right? And generally speaking, you see this part right here that's green. That's where lithium ion likes to hang out. All right. So if you want to extend your phone life, don't charge it all the way and don't let it discharge below 20%. Okay. Now, energy storage systems are the same way. However, there's this conundrum. You have to charge these things up to 100% once in a while just to keep the battery management system accuracy, accurate, right? Because if you don't charge these things to 100%, then what happens is the state of charge indicator starts to lose accuracy. That's the only reason. You're not going to hurt the battery, generally speaking, but it will shorten battery life if you keep it topped off or if you keep discharging that battery below 20%. And the battery manufacturers may have, a curve that shows how much you're losing, but generally speaking, it's negligible. And most people don't care, right? Like you want to top this battery off depending on the mode that you're in, right? Like nobody wants to leave 40% of the battery out when the grid's down and you're relying on your battery, right? So yeah, in all practicality, you shouldn't charge it up all the way, but that's just not going to happen. That's not realistic. All right. So now the last thing we'll talk about is state of health. Now, state of health is also represented as a percentage, and it tells you how much capacity is left. Okay. So if we have a brand new battery, this could be an energy storage system, could be on your iPhone, your Android, whatever. The capacity of that brand new battery is 100%. So if you charge it up to 100% state of charge and you start discharging, you can use 100% or 10 kilowatt hours of that battery. Okay. Now, over time, the capacity fades. That's just the way it is. Okay. And anybody with a cell phone, excuse me, anybody with a cell phone knows this to be true. Like I used to travel back and forth from California to the East Coast a lot, and I could charge my phone up in Sacramento and listen to music, scroll memes, whatever I was doing, and I could make it to O'Hare, or sorry, to Dulles on a charge and still have some left to grab an Uber. But 3, 4 years later, I got to keep that phone plugged in. Otherwise, I won't have any left when I land, right? So that's what's happening here. However, when you charge that battery up, it still says 100%. You still get 100% state of charge, but you don't get 100% of that original 10 kilowatt hours. You may only get 80% or 8 kilowatt hours. This is something that people have to understand because, 3, 4, 5, 6, 10 years later, you're wondering like, wow, why isn't my battery powering my house as long? That's why. This is just physics. Okay, so very quickly, the main parts of an energy storage system are the hybrid inverter. Need a little sip of dew there. All right, so the hybrid inverter, they call it hybrid because the battery and the PV connects to it. Generally speaking, there's a couple of different ways we could do this. Airs, I know we've talked about AC versus DC coupled systems. We could talk about that another time. But for the main parts, you'll also have a battery, of course. Airs, you talked about those batteries earlier, and I get this question a lot. Every lithium ion battery needs a charge controller, right? Or it needs a battery management system, which is just a fancy word for a charge controller, because lithium ion batteries differ from lead acid. In a lithium ion system, remember all those cells that I was showing you earlier? Each one of those cells is being monitored by the BMS. In a lead acid system, you have all of these batteries connected in series, you have the strings connected in parallel, and you basically end up with one positive and one negative that go into the inverter. And so or a charge controller. And so the inverter, battery inverter, or the charge controller only sees one positive and one negative. And it has to control the charging and discharging of all of those batteries. And it will do that. However, for lead acid, you have to charge those things all the way. Matter of fact, you have to do what's called an equalizing battery charge so that you get all the battery state of charge up to the same level. Because you got those guys all the way in the back on the end of the string that may not be charging and discharging as evenly as the ones that are right next to the charge controller or battery inverter. So lithium ion, we ain't got to worry about that because every cell is being monitored. It's being charged and discharged appropriately. So as long as you have a charge controller or battery inverter that meets the specs of that lithium ion battery, then you're good. No problem. And lastly, we have an automatic transfer switch or ATS. Any generator people out there? If you own a generator, a whole home backup generator, then you know what this is. Okay, this is a huge piece of equipment. It's switchgear. And if you have an energy storage system with batteries, of course, and if you want backup power when the grid is down, then you will need an automatic transfer switch. Now, some manufacturers don't call it that. They call it, like I think Tesla calls it a gateway or something like that. I know Enphase calls theirs a gateway. Whatever word they use, they're all doing the same thing. They are isolating the power that the battery and inverter and PV are making when the grid is down from the grid. So when the grid is down, you cannot export PV or battery power into the grid because you'll kill somebody that's working on the transmission lines during the outage, right? So you cannot do that. And UL 1741 is the doctrine that gives us that rule. Well, the automatic transfer switch isolates everything inside the home from the grid. Okay, so you have to have that. Now, these come in many different forms. You see here we got an EG4 hybrid inverter, we got some Fortress batteries, and we have another non-manufacturer from these other guys, an ATS. So you can piecemeal them together. That way you get exactly what you want, or it can be an all-in-one system. So a good buddy of mine, Mark Smith, no relation, but we were buddies at Sonnen together, and he works for this company here called Revolt. And everything that you need for the energy storage system is in that box. Isn't that cool? So a lot of benefits. There are a lot of benefits to either one of these, right? And so Eras, you guys do Solarc, right?
We're doing solar.
Solar, yeah. So I recommend that inverter when I'm doing my off-grid consultations. It's a solid thing. Like it's the matter of fact, it's the only inverter on the market that overtly says it's resistant to EMP attacks. I love it. So like all the zombie apocalypse enthusiasts like me, we gravitate toward that feature, right? I love it. So we'll take a look at some very simple electrical diagrams. It's not even a single line, really. I had an engineer, when I sent this to him, he said, "What do you have like a single or a three line? What's this cartoon drawing here?" I was like, "All right, but I forget engineers don't use the right side of their brain. I'll get you one. All right, hang on." So this is a Tigo system, but you could replace any of these components with anything. The Renview components, Tesla, SolarEdge, Enphase, EG4, Solar, it doesn't matter. They all basically look like this. So this is a partial home backup. And the reason that it's partial is because we have the main panel here. Excuse me. We have some non-essential loads. Those breakers are still here, but we come into this automatic transfer switch, and then we feed a little sub panel over here. And that sub panel has a lot of different names too. Protected load panel, backup panel, essential load panel, but it is never called a critical load panel. I hear that a lot, and it is wrong. If you're calling that a critical load panel, you are wrong. Strike that from your vocabulary because the National Electric Code has very specific litany for a critical or emergency load. Okay, you're talking about bank server backup, emergency egress lighting, life support system, and there are not very many energy storage systems residential that qualify for any of that. Okay, and I just quick C story. When I was at Sonnen, there was a guy and he said, "Oh yeah, I'm using a critical load panel." And the homeowner's like, "Oh, great." And so they installed this thing. And when they did the switch over, it took like 5 seconds for the lights to come back on. The homeowner flipped out because he was in the medical industry and his mother was on life support system connected to that backup panel. And he flipped his lid. when his mom's life supports didn't turn out. Well, you said it was a critical load panel. Installer like had egg all over his face. So don't use that word. All right. So we'll contrast that with a whole home backup. And so whole home, this is one way to do it. What we're basically doing is putting the automatic transfer switch between the meter and the main lugs of that main service entrance. Now, this may or may not be practical, depending on what kind of main panel you have, but there's these new things that are coming out called meter collars. Connector, Connect DER is a company that is making these things. And you still need utility support to do this because once you get to the meter, you can't touch that. The utility is shame on you. Do not touch our stuff. So you have to have them, but they come out, they pull that meter, they put this meter socket or meter adapter in there, and then they put the meter on top of that. Well, this socket or adapter has a little thing that comes off to do a tap. And so it's so much easier to do these whole home backups now. If you're, for example, if you have a combo panel where the meter is directly connected to the main lugs using bus bars, well, you can't cut a bus bar to do this, right? So the meter collars are a great solution for that. But as you see here, that main panel is at the mercy of any little thing that the battery has to feed. Everything. Okay. Anything you turn on now. And that's the beauty of this partial home backup. And I do, like the lottery, the pick six. That's what I recommend. Pick 6 circuits to put in this backup panel here that you want to run when the grid goes down, right? So, what are some common things or common areas of the house that you would want to have power when the grid goes down? Well, you're probably thinking, okay, the kitchen, because the refrigerator's in there, right? And so we're not backing up loads, we're backing up circuits. And so if you want the refrigerator to stay on, well, then you got to, back up the kitchen, probably the master bedroom, the living room, because that's where the router is, right? Things like that. So that's my advice, right? But when you're doing a whole home, every little thing that you turn on is now at the mercy of that battery. But it's very
Question
common.
about I have a question about the ATS. Is it important to have the ATS from the same brand of the inverter, or you can use GoodWe ATS with Tiger inverter?
That is a great question, Eras. And so the answer to that, like for most things in this industry, is 2 words. It depends. Well, so for Tigo's solution, it's closed loop. And that's just a fancy way of saying we don't work with anybody else except Tigo. Okay, except for the battery. Now, if the battery is an AC coupled battery, then you can use our inverter and ATS, connect the generator to the ATS, and that's fine. But you can't use our ATS with an EG4 or a Solarc inverter. It won't work
Uh,
because there is a communication cable that goes between the ATS and our inverter, and they only speak that language. So that brings up a great point. If you're piecemealing these things together, you need to make sure that everything is compatible. Yep, and that may take some data sheet diving. Yeah, good question. All right, so we'll talk about operating modes. Every energy storage system, every one of them for residential has 3, at least 3. And they're typically all called the same thing, right? So we have grid up modes, and then we have grid down modes. And there's also off-grid applications. Peyton Ayers and I were talking about off-grid. I get a lot of requests to actually write an off-grid book, and it's becoming more popular, believe it or not. And there's a reason why I didn't talk about that in my book has a very specific subtitle: Grid Tied Lithium Backup. All right. So that narrows it down. Gets rid of all the lead acid people, gets rid of all the off-grid people. Yeah. So we won't be talking about off-grid because that is a special animal. Although some battery inverter manufacturers will have an off-grid mode. They'll have it on there. Okay. So here's my attempt at dabbling with AI art on ChatGPT. Does pretty good in some areas, other areas not so much. And I can totally like see AI art now, and I'm kind of not digging it anymore. It's like, dude, stop being lazy. Just do some real stuff, right? But anyway, the first mode we'll talk about is backup. Okay, it is the least interactive of the three modes. It is the most boring of the modes. As you can see, the battery inverter here, he's got a bored look on his face. He ain't doing nothing. All he's doing is waiting for the power to go out. That's it. And so if your power only goes out a couple, three times a year, 5, 10 minutes, maybe an hour, maybe 2 hours if it's really bad, that inverter, that battery, it's not doing a whole lot. No, not doing a whole lot at all. Uh, the batteries stay fully charged all the time. Now, if you recall what I said earlier, the batteries don't like to stay fully charged, and that's true. But every BMS compensates for that. So they let the batteries discharge a little bit, and then they charge them back up. Right? And they just keep doing that, and that keeps the batteries healthy. Right? So that's normal. If you're looking at your monitoring system and you see the state of charge line like making little dips like that throughout the day, totally normal. It's supposed to do that, keeping the batteries healthy. Okay. Very few system settings, like you basically put it in backup mode, maybe give it a depth of discharge or state of charge, low end state of charge. That's it. Okay. That's what it looks like when the grid is down. And so if you look at the legend down here, red is consumption. Okay, that's how much energy the battery is feeling is being discharged. And then you can see here that green is solar charging, right? Oh, I'm sorry. This is the grid is not down. Sorry, this is a mislabeled slide. The grid is up. And I know that because this line right here, we'll see who's paying attention. What is this black line right here that just kind of very slowly throughout the day? If you look, this is midnight to midnight the next day. Just this little bitty line dropping down. Well, that's the state of charge. So I know that this battery is not discharging. Okay. It's sitting there. And that home is paying the utility for everything that it's using outside of this green section right here. Anywhere you see red, this homeowner is paying for that power. Okay. And I hate this mode. I hate it. And I tell our installers, don't put it in backup, even if the homeowner tells you to do that, because you're doing a disservice to the homeowner. Okay. Look at how much energy is wasted that they could be saving. They could be saving a lot of money here. And I'll explain that here in a minute. We get to self-consumption mode. Now, in this mode, the inverter is working a lot. It's getting a good workout. Matter of fact, if you go to Europe, this is the mode that they are all in, self-consumption. And that's kind of a self-defining term, okay? You're using your own energy to power your home instead of the utility. But now that depends on how well your system is designed. And if you can't match 100% of your consumption, well, then you're just shaving off your utility bill and your consumption with the solar and battery, which is fine. Right? You're still saving money. Right? So excess energy during the day, stored in the battery, and then you're just using the sun at night. Pretty cool. And when we look at this, wow, totally different picture here. Right here, we see all kinds of stuff going on. Right? We see that when this day started, they were at about 70% state of charge, and it went down. But look at this. Red means consumption, and blue means the battery is discharging. Anything below the zero line means the battery's discharging. But they don't have a lot of load here. Like that's nothing. That's not even 1 kilowatt. This is all what we call base load. Anything in their house that's on that has a remote control is drawing energy. Okay? The refrigerator kicking on, your DVR, your alarm clock, all of that stuff. That's what's drawing that power down. Isn't that crazy? And then you can see exactly when this person wakes up in the morning, 7 o'clock, turn the coffee maker on, turn the lights on, working around the house, and you see an increase in consumption. Yeah. Pretty cool, huh? So the battery got down to 20%, but then the sun came up right here, and look what happened. Got it all charged up. Look at that. He sustained the loads and charged the batteries up to 100% by what, 11:15? That's pretty good. Now I look at this and I can tell that this person, this is a partial backup because I tell you right now, ain't no whole home backup that has loads this low. Yeah. All right. Now the last mode is time of use. And in this mode, you are programming the batteries to discharge. So they're not discharging, all day, every day. They're only discharging when you tell them to. And so this is a typical utility um, time of use schedule, right? So spring has different timers, right? So the peak time is usually the same. It's usually 4 to 9, 5 to 10. That's when everybody's home using most electricity. But the off peak and super low peaks change. Okay. And okay, the utility is going to get their money one way or the other. Okay. They're going to get it. But what I like to call time of use is a focused self consumption. So, all that stuff we talked about in the self consumption mode, the system still does that, but it only does it in specific time windows. Like, for example, you'd set up your peak time from 4 to 9. So you're telling the battery, I want you to be fully charged before 4 p.m. And then I just want you to dump that battery and cover all of my loads for that 5 hours. And that's what a lot of people do. However, what I tell people is that you should play around with these settings because if you have your peak window, and most battery systems have 2 or maybe even 3 timers that you can set, if your peak window is done at 9 o'clock and you still have 40% state of charge, just open that window a little up. Just open it up a little bit more. Save some more money. It doesn't matter. You're not going to hurt anything. You can either open the window up on the front end or the back end and go more into the night. Doesn't matter. Not going to hurt anything. It's only going to benefit you. And here's Tom Hughes. Looks very, very similar to the self-consumption, but only in that window. So here, this person has their TOU set from 5 to 11. And so you see here that the battery gets charged up when the sun comes up, bam, stays at 100%. And then at 5 o'clock, when that timer starts, it starts discharging. Right there, slow and steady, just like that. And at midnight, they're at 30%. 30% state of charge, and that's when they stop. Not bad, huh? I think that's pretty cool. So quickly, we'll talk about some chemistries. And Eris, keep me on time because I'll talk about this all day. So we have cylindrical cells, which are the ones I showed you earlier. We have these pouch cells, which my previous company, that's the kind they used. And then we have prismatic. And these can be used anywhere. Yeah, they can be used in energy storage systems, but these are the general applications for them. Yeah. Prismatic, I remember when lithium was real big, back in 2015, 16, people would come up to my booth and they're like, oh, do you guys use prismatic cells? I think they just like to use that word. All right. And there's all the different types of cells, cylindrical cells out there. And you notice those numbers, they're all different. You notice there's different shapes and sizes, there's different heights, different widths. Yeah, that actually means something. Okay. Those numbers actually tell you the dimensions of that battery. So an 18650 is 18 millimeters in diameter and 65 millimeters tall. And I don't know, they just add a zero on there for whatever reason. Another common one for residential is the 26650. So it's still 65 centimeters tall, but it's a little bigger, a little wider in circumference. Yeah. That's all that means. Doesn't matter to us because you never see these anyway. They're always hidden, no matter what cell type they're using. They put them in a battery module, just like that. And then they take the battery modules and they put them in a battery pack. Now, this is an EV, right? Now, Teslas have over 6,000 cylindrical cells in their battery pack. It's amazing. I remember what I said. Every single one of those cells is being monitored by the BMS. It is amazing, amazing technology. Now, depending on the source that you're referencing, there's either 6 or 7 types of lithium ion batteries. And there are 2 that have gained popularity for residential, and they are these 2, NMC and LFP. And so Tygo and a lot of people use LFP. And when I tell some people that, they're like, well, I thought you guys use lithium ion batteries. We do. We're using lithium iron phosphate, which is a type of lithium ion. And when you compare and contrast this with nickel, manganese, cobalt, there are some advantages and some disadvantages, just like with everything, right? So, generally speaking, the industry is moving toward LFP mainly because of the safety factor and the tad bit higher lifespan. Okay, that's just what's happening, you know, like it or not. And so now you may see things that look like this, people punching nails through NMC batteries, testing like this to try to pump their LFP battery chemistry. I don't like these. Okay, I don't like them because all you have to do is change the type of nail that you're using, and you can get an LFP battery to ignite as well. Okay, so I don't like these kinds of tests, mainly because the National Electric Code does not differentiate between chemistries when it's making the rules for these lithium ion installations. They do not differentiate. Well, if you're using LFP, then you can do this. But if you're using NMC, you got to do this. Nobody does that. Okay. The NFPA 855, which is a heavily used doctrine for batteries that are installed, like in garages or things like that. It does not differentiate between chemistries. And the public doesn't differentiate. When they see a fire, whether it's an electric vehicle or in a home, they don't say, oh, well, that was an NMC battery. So, I don't have to worry about it. They don't do that. All they say is, oh, lithium ion batteries are unsafe. They're going to burn my house down. And that is not the message. Okay. These battery systems are very safe. They are tested with the highest standards of listed testing authorities. UL is the big one, and they're the ones that write all of these rules. And then you have these other testing authorities, these labs that use those standards. Okay, these are very, very safe. Very few fires or incidents. Okay, but when you do see one, it's like they make a big deal about it. Well, yeah, because they're so rare. Right? It's like an airplane incident, right? Those are so rare, but it's still the safest way to fly, or the safest way to travel, rather. Right? Same thing with lithium batteries. If you do what the manufacturer tells you to do, and you install it per their guidelines, you will have no issues. Now, lastly, we'll talk about sizing real quick. This is near and dear to my heart. And so what I would tell people is to be very wary of these quick sizing methods. If somebody asks you, "Oh, yeah, we're going to get you a battery bank. What's the square footage of your home?" I got this question so much that I made this t-shirt. This is an actual t-shirt that's on the snarkysolarguy.com store. Okay. And they asked me, "Oh, I got a 2,500 square foot home. How big of a battery I need?" And I'd be a little snarky and I say, "Oh, 2,500 square feet. Well, what color is the house?" And they're like, "What the heck does the color of the house have to do with my battery bank sizing?" Nothing. And neither does a square footage. Okay. I've seen a 1,300 square foot house consume 3 times more energy than a 5,000 square foot house. Okay. Square footage doesn't mean anything. And I know where this comes from. Generator websites ask you this when you're trying to size a generator for your whole home. Well, that's fine because they're using a fossil fuel or they're using gas to power your home. So as long as you have fuel for that generator, you can handle that. Battery systems are completely different. They may not have the surge that a generator has. May not be able to run as long as a generator can. So square footage means nothing to me. Another one that I see a lot is, "Oh, give me your electric bill." I use mine all the time on these sites, and they are not even close. They're not even close. They would probably take care of me in the wintertime, but summertime, I would be in trouble. Okay. So these two quick size, short methods, it's a lot of salespeople like to do it. The salespeople generally, they don't want to think about anything, right? All they want to do is make the sale, get it done quick, move on. So they use these kind of tools, right? And they're not accurate. You will get in trouble, I promise you, if this is what you're doing. Okay. So it takes some discipline. It takes just a little bit of effort to be able to do these correctly. Because remember, that AC panel, it's at the mercy of whatever you have on it. That battery, that poor thing may not last very long at all. So you need to size for the mode that you want, but you need to be aware that if you size for time of use, for example, which would be the smallest battery that you could size for, because you're only sizing for that 4 or 5 hour period, right? But just remember, every battery mode, the grid up modes, will switch to backup when the grid goes down. And so if you only have your battery system sized for that 5 hours because you only want a 10 kilowatt hour battery, because that's all you can afford, which I totally get it. It's easy for me to say, get a bigger battery because it's not my money, right? But just be aware that a 10 kilowatt hour battery system sized for a 5 hour time of use will probably not get you much mileage when the grid goes down. It's just not going to happen. Phantom loads I was talking about earlier, those will strain small battery banks, right? That little 40-watt light bulb on the porch left on all day, plus all the other thing. General rule, if you have something that requires a remote control, it's consuming 3 to 5 watts, period. Okay. And that stuff adds up after a while. And those shortcuts certainly don't account for the surge power or the startup power that these large loads need. Yeah. Anybody know how much current a 3-ton air conditioner needs to start? Anybody out there know? Yeah. 70 amps. 70. And there are not very many battery inverters out there that can do that. Okay. Got to be aware of all of the loads. Loads. Just like location. It's all about them loads. So here we go. Size the system for its main application for the most critical time of the year. Okay. And for you, it could be summertime, right? In Sacramento, it gets hot. Like we would have a month of triple digit days there. People don't realize that, but in that Central Valley, 113 degrees. I'd be in my garage working on my Mandalorian costume, my 3D print. I'd be sweating. It's like 120 degrees in the garage, right? So everything depends on your own area, and you know your area better than I do. Hopefully, better than the salesperson that's trying to sell you something does. And you need to ask these questions. And I do cover this in my book. I have some very pointy questions for customer advocacy to help protect you from the solar bros, is what we're calling them now. Yeah. Wintertime uses a different type, right? So, summertime, air conditioning takes a lot of surge power to get going. And then it will, slow down about 3,000 watts, which is still pretty sizable, right? But now, heaters, those are different kinds of loads, right? They don't have surge power. They just have a lot of power and they run for a long time, right? So you got to take all of that into account. You may have to take all of it, both of them, right? And then you may, if you always size for the worst case scenario, then you'll be covered for all of the other times of the year, right? And like people down in Florida that have outages, a lot of people I talk to, they are sizing for that, right? Their electricity is pretty cheap down there, but they're sizing for a week of no power because when the hurricanes come through, they just smack them around, right? They get slapped by those things. Yeah. All right. And lastly, the backup to the backup. A generator can greatly extend your autonomy. It does add um, more cost to the system, but a generator can be used to power those large loads. It can be used to charge the battery when you don't have a lot of sun or a lot of daylight to get the battery full. But remember, it's only used in backup only. You cannot run a generator in parallel with the grid. That is a no-no. That's why you always have an automatic transfer switch. And if you're going to do off-grid, you dang sure better have a generator. I cannot stress that enough. You better have a generator. The dirty little secret of these off-grid systems, I know people want to be green. They want to save the little penguins and the polar bears and their carbon footprint. I get it. But you need to take those rose-colored glasses off for just a minute because you're going to be running that generator probably 300 to 400 hours a year in off-grid. Guarantee it. Guarantee it. Ask me how I know. Yep. All right. So that's it for generators. And that's it for me. Key takeaways here. Learn the lingo. It's so important that we all speak the same language and just understand there are different parts of the ESS, even though they may be called different names. They almost always have different specs, but they all do the same thing. And then they all share the same basic functions, regardless of make and model. Yeah. So that's it for me.
Great, thanks. Thanks, Greg. There are a couple questions, so if anybody have questions at this point, just use the Q&A button of the Zoom pan. Other than that, let's go over the few questions that we already have there.
Yeah.
One person is asking, what if the power goes out at midnight? I think they asked it when you said that you should discharge your battery during the day.
Yeah. I know exactly what you're asking. So you're asking, well, okay, you're telling me to discharge my battery as low as I can to save money, but then at midnight, if the power goes out, I got no battery. Great question. And battery manufacturers will compensate for that by giving you a setting that tells you the lower limit that you will allow the batteries to discharge. So a lot of people, they will discharge a battery. 20% seems to be a very common uh, low level, right? Almost every battery system will stop discharging at about 10%. They don't want you using any more than 10%, right? But a lot of people will set their discharge limit to 20%, although I've seen people limit it to 60% in the wintertime because they know they have a lot of outages. And so that 60% will get them to the next day when the sun comes up. Yeah, that's a great question.
The next question is, should we get a generator if we want backup batteries? If we want backup, batteries are expensive.
So, are you asking you want a generator instead of batteries or with the batteries? So, again, it depends. And there's a lot of benefits, right? If all you want is something to get you through a tough period without grid, well, yeah, the generator is going to be the cheapest option. Absolutely. Like there's no denying that. You just have to make sure that you've got enough fuel to get you through. All right. I had a buddy of mine in New Jersey when I was at SMA. There's another guy lived out in Pennsylvania, and a guy in New Jersey had a power outage. He had a generator, but the gas stations closed down. And so now what? And so the guy from Pennsylvania, they met halfway, exchanged 5 gallons, 10 gallons of gas, and the guy went back to New Jersey. So you never get something for nothing, right? So if all you want is backup, then certainly a generator is a cheaper way to go as long as you have fuel. And that's the beauty of a complete energy storage system is you have the solar, you have the batteries, you are saving money throughout the year on your utility bill. And then when times get tough, you have your energy storage system to get you through. And then which means you only need a small generator for those times when you don't have enough sun to charge the batteries, or if you have some larger loads that you need to run that the battery system may not be able to handle for very long. You just start the generator up. Yeah, another good question.
Also, I think that we need to talk about the price of batteries. It goes down significantly every year. I just presented an option of 2.5 kilowatt hour battery for $480. This is ridiculous. I mean, this is so low.
It
Uh,
really is. Like, and I know in my book I show a graph. I think in the last 30 years, the prices of lithium ion batteries have come down 95%.
yeah.
Okay. And they keep coming down as the technology gets better. It's one of the few things really in our economy, other than, those big LED TVs that are coming down in price. Most everything is staying the same or getting more expensive.
Richard is saying here there are a lot of DIY batteries kit available. Why not to go with DIY instead of buying those pre-made, pre-packed packages?
Yeah, I can appreciate the DIY, right? Like being here in Arkansas, I can appreciate the redneck engineering component to that, right? Like I do that. And there's nothing wrong with DIY as long as you understand what you're doing. But and I have many, many friends in this industry. Like I said, I've been doing this 17 years. I talk to all the other trainers from every other major battery and inverter manufacturer. And I wish I had a beer for every time a DIYer called me with an issue. I would never have to buy beer again. So as long as you understand what you're getting into, and if saving that little bit of money is worth it to you, rather than getting a full turnkey solution with monitoring, with the warranty, if that's your thing, go for it.
All right, another question here. Can I use ATS to switch between two solar energy systems? I have a 5 kilovolt system with sun on inverter that does not require a battery backup, which I run during
Yeah.
that day, and the 7.5 kilovolt
Wow.
that I
Wow.
run at night.
I love this industry because we always get I'm not a crazy question. That's not fair. Interesting applications, right? And so if I understood you right, you've got two different systems feeding a panel, and you want a switch to be able to go back and forth between them. So when the batteries get low over here, you switch over to that one or whatever the application is. So the short answer is yes, you can do that. You better make sure, and I speak from experience with this, you cannot have two different battery manufacturers, two different energy storage systems feeding the same panel. You can't do that because the two different systems don't talk to each other. And if they're trying to feed the same electrical panel, they get confused because they're trying to charge and discharge the battery. They're feeding loads, they're gathering consumption information. And so they both get confused, excuse me, and they will just stop working. I saw this many, many times. Had a guy that kind of did something like that. He wanted to have like an existing lead acid battery that was aging out. He wanted to install a new sawn-in system, but he wanted to use the existing lead acid battery system as the grid to fool the sawn-in system. And then when the lead acid system finally went, he would just switch over. He didn't clear this with anybody. He just thought that it would work. Kind of makes sense, but it doesn't. It does not work. So as long as you isolate both systems, and I don't know of any way for an ATS to automatically switch based on state of charge between the one system to the next, it's probably going to have to be a manual system switch over, which means you're going to have to be paying attention to both systems, and you're going to have a way to charge both systems. Yeah, that's a complicated one. It's doable.
Yeah.
Anything's doable. Anything's doable. Just depends on how much money and patience you have.
Last question here. Can you comment on the utility interconnection approvals needed for a UL 1741 ATS that can also parallel loads?
Yeah. So I understand the sentiment for that question, right? Because utility companies are very, very um, protective of their interconnection. Yeah. And so if you see an ATS with a 1741 um, listing, and that should be okay. Okay. Now, there are some, and this is where some utilities get confused. There was another listing for an automatic transfer switch used in emergency applications. Okay. That requires a different certification. And I think because the switching has to be faster. And don't quote me on this, but I think it's like UL 789 or something like that. Okay, that specific UL requirement is only for an ATS in that very critical specific application. For a standard residential battery backup system, you don't need that. However, there's a lot of inspectors out there who don't still understand energy storage. And so they may be still applying a standard that doesn't apply to batteries. Like I see this all the time where they ask, well, you need to have this or that or that. And it's like, well, an energy storage system doesn't need that extra stuff. You're thinking about a generator and you're applying those generator requirements to an energy storage system, and you don't need that. So, generally speaking, if you are using a name brand product, right, and not some cheap Chinese or whatever product, those are tested and listed, right? So my advice to you, especially for the person that asks about the DIY, you need to make sure that every component is listed. And if you're going with a reputable manufacturer, and Renvu is only going to use reputable manufacturers, they're not going to use these one off crazy stuff that's super cheap that's going to get you in trouble. Okay. If you're using name brand stuff, you don't have to worry about the listings because they have them listed. Like they've been around a long time. They're not going to jeopardize their business by trying to float something past an inspector that's not tested or listed.
Sounds good. And another question here came just now. My electric power utility is requesting to use my battery storage on my system and are willing to compensate for that use during peak time. Why would I want to or not want to? That
Ooh, man, we're getting some good questions, Eris. So that is very popular. And so we'll tackle that. Why would the utility want your power during the peak times? Well, because you have all the air conditioning going on, you have everybody coming home from work, and so the demand is high. And so this is very common in a lot of places that use virtual power plants or interconnections that ask you if you want to participate in this program. And so what you need to do is figure out if the compensation you're getting, and they won't use all of your battery generally. Um, and you need to look at the agreement for that. Okay. They will generally only discharge to about 30 or 40%. They're only using a little bit, but they're using a little bit from all of the people in their interconnection area, right? So it works out for them. So you need to ask yourself, is cycling my battery for 2 or 3, 4 hours a day worth the compensation that I get? Right? Because what they're going to do is pull that power from your system. And so this takes what's called a line side tap, right? And so what they're doing is they are going around your main panel. Okay? You are not offsetting any loads during that time. And there's a lot of ways to skin this cat, but this one is more beneficial to the utility company. So they put you between the main and the meter. And so they can just suck that out anytime they want. So you don't get any of that. And so is it worth it to you to get the scraps from the utility for your energy? Or is it more worth it to just use your own energy to power your own house during that 4 or 5 hour time? That's an easy exercise. Matter of fact, that sounds like something Chat GPT would be able to help you with. If you upload the agreement to Chat GPT and then type in there, this is what I'm paying per kilowatt hour during this high peak period. Is it worth it for me to go into this program for the utility or just use it myself? I guarantee you ChatGPT would answer that question very accurately.
sounds good. Okay.
It's so
Didn't know
cool.
that you're going into AI now.
I know everybody's
Sounds like,
scared of AI, but I use it all the time for stuff. Now you have to check it because I've caught
yeah.
it a few times, but for stuff like that, it'll spit that thing out in 500 milliseconds. Boom.
Oh, I think we got to the bottom of it. Thanks a lot, Greg. That's another fun webinar with you. I hope that we will have more in the future. Uh, Alfredo is asking if we're getting access to the recordings or slides. Yes, we will share the recording of this webinar in a follow-up email with everybody. We also have, how is it called? A recording uh, that you will be able to just listen to like an audiobook. after the webinar ends, and we will share that as well. That's it. Thank you, Greg, again, and have everybody have a great rest of your week. See you later.
Thank you.
Bye.